All right, so today we are going to be working through what are called your molar conversion guided notes here. This paper you should already have from the last stack, so it should be after your percent composition and empirical formula notes, okay? So what we want to get to today is we want to talk about how we can convert things from grams to moles, okay? Because we often measure substances by their mass in grams, right? Like we have things back in the lab that we can use that measures things in grams. So one of the ways, obviously, that we can get things in grams is by reading it on an electronic balance, which are those things in the back that we've been using. We used them for our bubblegum lab. We've used them for other labs where we have to weigh out a certain amount, but those measure things in grams. Another way that we can get grams of a substance is indirectly through volume and density, okay? Because density is mass divided by volume. And so we can find mass in grams if we're using the density equation, okay? So those are two of the ways that we can determine this. One way, this would be like if we had a solid, we could just throw it on a weighing tray, get the mass of it. If we had a liquid, we would have to measure the volume, use the density to then find the mass, okay? But because every single substance on the periodic table, every element on the periodic table has a different molar mass, okay? We can't compare 5 grams of magnesium to 5 grams of copper because they have two different molar masses. So in order to compare substances in a balanced chemical equation, we must first make sure that all quantities are converted to moles. Because moles is a universal unit. 1 mole of magnesium is the exact same number of particles as 1 mole of copper, okay? And remember that there are 6.02 times 10 to the 23rd particles in 1 mole, okay? So for time purposes, and because my time is limited here with you guys for this year, we are actually going to skip going over the conversions with Avogadro's numbers. So you can go ahead and draw an X through these, okay? But we are going to talk about the different particles that we could potentially see. So whenever you see the word particles, they can mean different things in the world of chemistry. If it is an ionic compound, the particle would be called a formula unit. Okay, so that's just the name of a particle for an ionic compound. If it is something that's covalently bonded, or if it's a diatomic element, we can call those molecules. Okay, or if it's just like a monatomic, like some copper, we would just call it an atom. Okay, so these are just 3 different words. They're all types of particles. There's that type, and that type, okay? And it just depends on what the actual substance itself is. But we're not going to do any conversions between particles and moles just because of time's sake. So what I do want you to do is go ahead and flip it over to the back side. And we're going to look at conversions between moles and grams. So we're either going to go from moles to grams or grams to moles, okay? So remember that the mass of 1 mole of a substance is called the molar mass, okay? You guys have been using molar mass a ton. Not only did you guys, most of everybody aced their molar mass quiz, we've used it in our crime scene when we were working with empirical formulas and molecular formulas, so we've used molar mass a lot, okay? So to go from mass to moles, okay, so if we're starting with grams of something and we want to get to moles of something, we are going to end up dividing by that substance's molar mass, okay? So that would mean that we would use this version of a conversion factor. If you remember, molar mass uses the units of grams per mole. One way to write this is 1 mole of something is the molar mass, or I could even flip it and say the molar mass is 1 mole. These are like multiplying something by 1 because they're the same quantity, just in different units. Okay, so let's just do an example here. It says in lab, Chandler measured that there were 4.02 gram sample of copper chloride, and we want to figure out how many moles of copper chloride does Chandler have. Okay, so this original number that is given to you is what I call the given. Okay, and the given will always go right here in that top left part. I call this a bracket. Okay, that's my starting quantity. Nothing at all goes down here. So I always tell students to scribble this out because they're likely to be tempted to write something there. Okay. Now, the way that I'm going to have you set this up is a way where we want to cancel the units that we're starting with, so grams, and we want to get to the units that we're trying to end in, which is moles. Okay. So I know that when I'm going from grams or mass to moles, I need to divide by the molar mass. Okay, so I'm going to set it up like this. Well, I need to know the molar mass first. So the molar mass of CuCl2 is going to be the mass of a copper. I didn't have my periodic table ready here, so let me get one out. Okay, so the mass of 1 copper is 63.55 plus 2 times the mass of chlorine, and chlorine has a mass of 35.45. Okay, so we're going to figure out what that molar mass is there. Now I'm just going to type it into my calculator. So 2 times 35.45 plus 63.55. So the molar mass of copper chloride is 134.45 grams per mole. Okay. So I'm going to change up my colors here since I just took a bunch of space up. So how I write this now, since I'm dividing, this number is going to go on the bottom. 134.45 grams of copper chloride in every 1 mole of copper chloride. So all we're doing, this is just dividing by the molar mass here, okay? Grams goes on the bottom because if a unit is on the top and on the bottom, it cancels out. We're left with moles of copper chloride, which is essentially what we're trying to get to here, okay? So since we're left with the unit that we want, now all I want to do is do a little bit of a multiplication problem here. Well, multiplying and dividing, I guess. Okay, we multiply everything across the top, so that'd be 4.02 times 1, which is still just 4.02, divided by 134.45. Okay, so this is my answer here. I'm going to go ahead and round that. We'll round it to 0.0299, we'll say. Okay, and how I label it is whatever is left up here on top that hasn't been canceled. So I'm saying that I've got 0.0299 moles of copper chloride. Okay, and I always like to put a cloud or a circle or something around my final answer there. Okay, so if ever I start with grams, I divide by the molar mass. Always opposite of that will be 1 mole. Multiply across the top, divide across the bottom to get my answer. Okay, let's do another one here. This time, it says how many moles. So once again, I'm solving for moles. So I know that needs to be my unit up here in the top right, are in 11.57 grams of NH420. Okay. Anytime I see grams in a problem, I know that I need to solve for molar mass. So I'm going to solve for that molar mass over on this side this time. Okay. Remember, you don't have to show me your work for this anymore, but I'm just showing it to you for in case you forget. So this 2 multiplies to this nitrogen. So 2 times 14.01 plus, we've got 8 times the mass of hydrogen plus 16, which is the mass of oxygen. Okay, so 2 times 14.01 plus 8 times 1.01 plus 16. The molar mass is 52.10 grams per mole. Okay, so I know I'm going to end up using that in my bracket here. Okay, so this is now saying we want to solve for moles. We're given grams. Remember, whatever number is given to us goes in this top left. So this becomes 11.57 grams of NH420. And yes, I want you to include all of that, okay, because these are going to get more complicated, and we want to have the substance that we're dealing with there. Nothing will ever go down here, so I'm going to scribble that out. Since I'm starting with grams, I want to get rid of grams, so I'm going to divide by this number. So there's going to be 52.10 grams of NH420 in every 1 mole of NH420. Okay, I'm going to make sure my units cancel. So grams cancels with grams. I'm left with moles, which is what this problem is asking me for. And now I'm going to multiply across the top and divide by the bottom. So 11.57 times 1, which I'm not going to type, divided by 52.10, and I get 0.222. What are my units? Whatever left on top here that wasn't canceled out. So that would be moles of NH420. Okay, and that is my answer. That's saying this many grams is equivalent to this many moles. That's all we did was convert the units. These two quantities are the same, they're just in different units. Okay, so whenever we're going from grams, remember mass is just grams, to moles, we're going to divide by molar mass. So mass is going to go on the bottom, 1 mole will go on the top. So now we're going to look at the opposite of that. Okay, what if I want to go from moles to grams? So I'm going to go in the reverse. Well, instead of molar mass being on the bottom, I'm actually going to multiply by it. It's going to go on the top. Okay, but everything else is the same. Okay, so this one says Rachel is supposed to start her lab with 3.066 moles of sodium chloride. How many grams, okay, should she measure out? So once again, this is what I'm starting with. This is my given. So I'm going to write that in the top left, 3.066 moles of NaCl. I'm going to scribble out that bottom. And I need to multiply by the molar mass. So let's go ahead and calculate our molar mass here. I've got 1 sodium, which has a mass of 22.99, plus 1 chlorine, which has a mass of 35.45. And if I add those two together, I get 58.44. Okay, now we're saying, since we're going opposite, moles has to be on the bottom here. So 1 mole will go on the bottom in order to cancel those out, and the molar mass will go on top. Moles of NaCl cancels. I'm left with grams of NaCl. And once again, whenever we're in this bracket situation, we multiply everything across the top and divide by everything across the bottom, which the bottom is just ones here right now. So I just need to take 3.066 and multiply that by 58.44. And I'll round this to 179.177. Okay, what are my units? Well, what did not get canceled? Grams of NaCl did not get canceled. Okay. So if I had 3 moles of NaCl, it would be equivalent to almost 180 grams of NaCl. Okay, these two quantities are the same, they're just in different units. Okay, it's just like saying, you know, you're 150 pounds. Well, how many kilograms is that? You're the same weight, just in different units. Okay. All right, we'll do one more. This one says Ross has 6.215 moles of fool's gold, and fool's gold is FeS2, and that's stored away in his attic. How many grams of FeS2 does he have? So I'm going from moles of FeS2 to grams of FeS2. And whenever I'm going from moles to grams, I'm going to multiply by the molar mass. My given goes in the top left, just like always. I'm going to scribble out that bottom. Okay. In this case, we know that 1 mole has to go on the bottom to cancel the units. And now we just need to solve for our molar mass of FeS2. Okay, well, Fe has a mass of 55.85 plus 2 times the mass of sulfur, which is 32.06. Okay, let's calculate that. And that comes out to 119.97 grams per mole. Okay, and we already have our per mole part listed. And so we just have to say there's 119.97 grams of FeS2. Moles cancels, left with grams. I just need to multiply across the top. 6.215 times 119.97. So I get 745.614. 745.614. And once again, whatever my units are left on top. Grams of FeS2. I'm just going to cloud that. Okay, so just a reminder here, anytime you have grams in the problem, you're going to have to solve for the molar mass of whatever the substance is. Okay, if you're going from grams to moles, I'm going to divide by that molar mass, so it should go on the bottom. If I'm going from moles to grams, I'm going to multiply by that molar mass and show it should go on top. So next up, you're going to get one of these worksheets here. Okay, you're only going to work on numbers 1 through 6. Okay, I've already blacked out that bottom left where I was scribbling earlier. Okay, you're going to complete the following molar conversion problems, which is just what I did. I did 4 of them already for you. Use those as reference. Okay, circle your final answer and make sure that you have the correct units on it. So it should be labeled grams or moles and whatever the substance is. These are not going to tell you whether to multiply or divide, so you really have to look. Okay, this is saying how many moles are in grams. So I'm starting with grams, I'm converting to moles. Okay, if I'm starting with grams and converting to moles, I'm going to divide or go on the bottom. This one says how many grams are in 0.233 moles. So this one I'm starting with moles, I'm going to convert to grams, moles to grams, we're going to multiply. Okay, so your notes should be your guide. You will have to calculate molar masses, but you do not have to show me that work. You just need to be placing them in here properly. I'd like to see your units canceling. I'd like to see your final answers circled with proper units, okay? Just numbers 1 through 6 today. All right, have fun with that, and I'll see you tomorrow.